All right, by request, 7.5, number 55. In this case, it's a rational equation. You want to make sure those denominators are not zero. So I'll start by saying x cannot equal 0 and x cannot equal a negative 1/3. So that just allows me to kind of, when I get to the end of this problem, make sure that I have everything done correctly and checked my work. Multiply both sides by the LCD. The LCD in this case is 3x times the quantity 3x plus 1. If you multiply both sides of this equation right here by that, you will get 4 times 3x plus 1 plus 3 times 3x plus 2 times 3x plus 1 is equal to 0. At 2 times 3x plus 1 usually throws people off, but you're multiplying each term in that equation by the LCD. Distributing around, we get 12x plus 4 plus 9x plus, I'll write this as 2 times, and then I'll distribute that 3x through, so I get a 9x squared plus 3x is equal to 0. Combining some terms here, let's see, 12x plus 9x is a 21x. Plus 4 plus, now I'm going to distribute that, 18x squared plus 6x is equal to 0. And rewriting it one last time, 18x squared, 21x plus 6x is a 27x. And then finally, plus 4 is equal to 0. And now you have to see if that factors. Gosh, I really hope it does. That's a bit of a mess. I'm going to do the guess and check method here. Before I do, I want to make sure that I did all my mathematics correct, because if you don't, you'll be stuck in a loop for quite some time. It looks like I did, though. To get 18x squared, you could get an 18x times an x, or you can get a 2x times a 9x, or you could get, right, a 3x times a 6x. Now, in those three options, I will probably choose either the 2 and 9 or the 3 and 6. So let's see, we want to get to 4. Geez, actually, now that I'm looking at that, yeah, now that I'm looking at it, I'm going to say the 18 is the only possibility that's going to be. Mainly because it just looks like that's the only possibility. Um, Yep. Okay, so if you did that, it'd have to be 1 and 4, or 4 and 1, or 2 and 2, and that's about it. But if you multiply through, uh, remember, outers and inners, that'd be 54 and 1. That doesn't work. That doesn't get to 27. 18 and a 4 doesn't get to 27, and then 36 and a 2 doesn't get to 27. You try these other ones, but I'm going to guarantee they will not work. Now that I'm looking at that, they just will not. So, that being said, I'm going to just quickly once over this work and make sure that I did everything correct. And taking a few moments to check, it does look as though I did everything correct. So now I guess I will just go ahead and dive right into quadratic formula, because that will not factor nicely. The opposite of the b term, plus or minus that b term, the square root of that b term squared, minus 4 times a times c all over 2a. And let's see, it's a big old fraction, negative 27. I'll need a calculator here, so plus or minus the square root of 441. That's what that compresses to. And twice 18 is 36. The square root of 441 is 21. So it's negative 27 plus or minus 21 all over 36. That means that it actually would have factored. So not 100% sure. Do they have anything in common? Oh, I know how it would have factored. You probably not following why I'm saying this means it would have factored, but it does. It means it would have factored because 8 and 9. No, that doesn't work out. It's not 27. How about this one? 4 and a 1. Outers and inners. 24 plus 3. Oh, yep, it does factor. Yep, 3x plus 4 and a 6x plus 1. It factored down. Yeah. So that's what this factors to, even though the quadratic formula would have gotten us the right answer. But notice if I had spent a few more seconds testing out these values, I would have found out that it does factor 3x plus 4 and a 6x plus 1. And so rather than doing this quadratic formula, which will reduce down, I could have said, oh, but this is 3x plus 4 times 6x plus 1 is equal to 0. Or in other words, x is equal to negative 4/3, or x is equal to a negative 1/6. And that's actually what it'll reduce down to in the quadratic formula as well. Neither of these are the red values in red there, so they're valuable answers, they're viable answers is what I should have said there. Anyhow, that's how that problem is done.